Research question for a system administrator by Al-bhaser S. Kumar, 11 to 20. Number 11. What is RFC 1918? An RFC 1918 address is an IP address that assigned by an enterprise's organization to an internal host, which is this IP address are used in private networks which are not available or reachable from the internet. In fact, one of the best requirements for the internet is that each host a unique IP address. So RFC 1918 removes this requirement. RFC 1918 IP address can be used on multiple networks as long as they are private and isolated from each other. To implement this solution, every internet router must be configured to discard IP packets, which these addresses, IP packets carrying private addresses, can only flow on internal private networks. Another brief history for RFC 1918. This RFC was drafted in 1996 when it becomes clear to internet operators that the IP version for address space consisting of 4,294,967,296 unique addresses was not sufficient to address every single computers in this world. By that time, the internet was rapidly growing beyond initial expectation. Soon, no IP version for address will be available to use, limiting the internet's growth. As a solution, RFC 1918 was drafted to enable private organization to use this address. Internally, private addresses can be used without asking permission to the Internet Assigned Number Authority, which governs the IP address assignments. Another history for C1918 subnets. The RFC 1918 addresses a space including the following network: 10.0.0.0, which is prefix niya is 10.255.255 and 255. In this figure show is the 10 dot network, which is the 10/8 is typically used within a large organization that have thousands of hosts. And the second figure, the 172 and 192 are the subnets are more common within smaller organization or home networks. If you are reading this article from home, must be probably your laptop is configured by a DHCP within a 192 address. Number 12 is what is CIDR? CIDR is classified by classless interdomain routing. CIDR classes interdomain routing, also known as supernetting. It is a method of assigning internet protocol, which is IP addresses, that improves the efficiency of address distribution and replaces the previous system based on a Class A, Class B, and Class C networks. The initial goal of CIDR was to slow the increase of routing tables on routers across the internet and decrease the rapid exhaustion of IP version 4 addresses. As a result, the number of available internet addresses has greatly increased by CIDR. CIDR is based on a variable length subnet masking, or VLSM, which enable network engineers to divide an IP address space in a hierarchy of subnets of different sizes, making it possible to create subnetworks. with different host counts without wasting large number of address. And there is a figure up there, like you can identify for a subnetting for CIDR notation. There is a picture above there, you can see it. Number 13, you have the following network ID: 192.115.103.64 by 27. What is the IP range of your network? For this problem or this question, I use the IP calculator subnetting network, which is it's shown their figure, like you can see there the IP address, network address, and based on this question is what is the range of this IP address, which is the 192.115.103.64 by 27. So the usable host IP range is 192.115.103 by 65 is 192.115.103 by 94. The total number of hosts is 32, and number of usable hosts also is 30, and the subnet mask is 255, 255, 255, and 224. And IP class niya is class C. Then CIDR notation niya is 24, which is IP type niya is public. Number 14 is you have the following network ID, which is 131.112.0.0. You need at least 500 hosts per network. So this IP address was 131.11.2.0.0. The network address is same. Usable host is, the range is 131.112.0.1 hanggang 131.112.0.126. That is the usable hotspot range niya. Broadcast address naman is 131 by 11.2 by 0 by 27. Total number of hosts is 128, and number of usable hotspots is 126. And the subnet mask is 255, 255, 255, 128, and wildcard mask is 000127. IP class niya is C, then CIDR notation niya is 25, IP type is public. So it's mean you can address a 500 host per a network, which is the 255, then plus 255. You can create more than 500 network per host. Question number 15 is referred by question 13 and 14. How many network can you create? What subnet mask will you use? In this question is, I refer the two figures, which is yung question number 13 and 14. Question number 13 and 14. Yung 131 and 112.0.0 and 192.115.103.64. Network can create is 128 for the IP address 131 and 112.0.0. Ang naman niya is, ang subnet mask niya is 255 by 255 by 255.128, and IP class niya is C, and CIDR notation is by 25. Next is the question number 14, the 192.115.103.64 5.115.103.64, which is the subnest mass niya is same as question number 13, which is 255 by 255 by 255 by 224. Then IP class niya is C, and CIDR notation niya is by 27. IP type is public. Question number 16. You need to view a network traffic. What will you use? Name a few tools. For me, the best, I choose the most 5 best network traffic tool for to view a network traffic. First is monitoring network traffic, which is defined as the data moving across your network at a given time. It is important for any business looking to maintain a fast and efficient network. Automating network traffic monitoring and analysis with the support of the tool can help in terms reduce downtime, identify the causes of bottlenecks, boost the efficiency of troubleshooting efforts, and more. As with so many essential network management and monitoring tools, the market is become saturated with network traffic monitoring options. This can make process of choosing the right one overwhelming. In this guide, we'll look at the top of tools currently available so you can find the right solution for your business. If you want to keep ahead to the list, you can do so here. So here are some of the 5 best network traffic monitoring tools, which is one is a SolarWind Net Flow Traffic Analyzer. Second is SolarWind Network Performance Monitor. Third is SolarWind's Bandwidth Analyzer Pack. Fourth is what is this? Pfizer Party Network Monitor, and last but not the least is Managing Net Flow Analyzer. So let us define the SolarWind Net Flow Traffic Analyzer. SolarWind Net Flow Traffic Analyzer, or the NTA, is an intelligent scalable net flow analyzer with bandwidth monitoring tool offering service including network traffic analysis, bandwidth monitoring, advanced application recognition, and VMware and vSphere distributed, which support application traffic alert and more. Second is SolarWind Network Performance Monitor, or NPM, is another great option for anyone looking for a powerful network traffic monitoring solution that can grow with your business. And multi-vendor network monitor can deliver utilities that support network traffic monitoring, including cloud service monitoring, Cisco network monitoring, LAN monitoring, router traffic monitoring, link analysis, and more. As a broad network monitoring, NPM continuously monitors your network for fault availability and performance of your devices and application. Third is SolarWind Bandwidth Analyzer Pack, or the BAP. If you're intrigued by both SolarWind NTA and SolarWind NPM, there is a perfect tool for you. The Solar Network Bandwidth Analyzer Pack, or BAP, a network traffic monitor solution that combines net flow traffic analyzer, which is the NTA and NPM, to both enhance and simplify the traffic monitoring process. Fourth is Pfizer Network Monitoring, or the PRTG Network Monitoring. takes a sensor-based approach to network monitoring with thousands of different sensors to choose from. This approach empowers you to create either a specialized network traffic monitoring solution or a more comprehensive network management and monitoring solution based on your specific interest. And last but not the least is the Manage Engine Net Flow Analyzer. The last tool on this list is another popular versatile network traffic monitoring and analysis solution. In addition to traffic monitoring, Manage Engine Net Flow Analyzer can also function as a usage monitor, protocol analyzer, application monitor, web traffic monitor, Cisco ASA monitor, and more. NetFlow Analyzer generate in-depth network traffic reports using flow data that is stored for analysis. It collects data from sources including SFlow, NetFlow, IPFix, and JFlow, and the tool then correlates the data and display it is more user friendly readable format like other tools on this list. NetFlow Analyzer use graphs and comprehensive reporting to help information technology teams stay on top of network traffic behavior provider. Next is the how do I know the path that a packet takes to the destination. You can run a tracer route command on almost all Windows platform including XP, Vista servers, Windows 7, 8, 10, and etc. Starting by opening the command prompt, go to start, type in CMD and press enter. And next thing you do is use the tracer command, type in tracer along with the target to tracer a route towards a destination so you can find the packet destination. There is a figure that's shown by network packet to take the destination you want to find. So routing up IP packets is our example, which is you can see there the network that travels to another network, and to the IP packet network, which is the yellow one that's shown there in the picture. IP packet analyze the operation of every IP packet or IP network that will provided by the IP host. What does the ping 192 by 168 by 0 by 1 negative L 1000 negative N100 command do? The IP address 192.168.0.1 is the most common address to access and configure wireless routers from a web browser. It is a default address because the specific IP address range are reserved for different types of network, and 192.168.0.1 is reserved for networks such as your home LAN, local address network. The reason 192.168 exists is so that you do not need to ask someone else for an address, because it is provided by your home local area network. with anyone else because 1,000 addresses may use. You can pick one that start with 192 by 168 and there will be no conflict with anyone else because those addresses may only use in your network and are not used by some outside your network to reference your machine. Number 20 question is, what is DHCP? What are the benefits and drawbacks of using it? So first of all is, let us define what is DHCP. A DHCP server is a network server that automatically provides and assigns IP addresses, default gateways, and other network parameter to client devices. It relies on the standard protocol known as Dynamic Host Configuring Protocol or DHCP to respond to the broadcast queries by clients. A DHCP server automatically sends the required network parameter for client to properly communicate on the network. Without it, the network administrator has to manually set up every client that joins the network, which can be cumbersome, especially in large network, to be aware. So DHCP servers usually assign each client with a unique dynamic IP address, which changes when the client's lease for the address has expired. What are the benefits and drawbacks of using it? Dynamic Host Configuring Protocol or the DHCP is a network management protocol used to automate the process of configuring devices on IP network. So, thus allowing them to use network services as DNS, NTP, and any communication protocol based on UDP or TCP. A DHCP server automatically assigns an IP address and other network configuration parameter to each device on a network so they can communicate with other IP address. DHCP is an enhancement of another older protocol called BOOTP, and DHCP is an important part of DDI solution. Last is, describe the steps taken by the client and DHCP server in order to obtain an IP address. When to use a router switch as your DHCP server. There are many enterprises companies who are still using DHCP for IP version 4 on their routers or switches. This is typically done by network administrator who needs to get a DHCP capability up running quickly but doesn't have access to a DHCP server. Most routers have the ability to provide the following DHCP server support. First is a DHCP client and obtain an interface IP version 4 address from an upstream DHCP server. Second is a DHCP relay and forward UDP to DHCP message from a client to a LAN to a form of a DHCP server. Third is a DHCP server whereby the router service requests directly. However, there are limitations to using a router as a DSCP, accelerated forwarding. So it is not hardware accelerated forwarding. The resources required make this practice not suitable for a network with a large number, which is greater than 150 of DHCP clients. Fifth is does not support dynamic DNS. So take note, dynamic DNS. The router DSCP server cannot create any entry into DNS or on behalf of the client based on the IP version for address that was leased to the client. Next is no ability to actually manage the scope and see the current DHCP binding and leases across multiple routers. Administrator must log into the switch or the router individually to get information about DHCP bindings. Next is no high availability and redundancy of the DHCP bindings. This could be cause problem if the current DHCP server and default gateway fails. Second to the last is it is more difficult to configure DHCP option on router or switch platform. Last but not the least is the DHCP server running on a router switch is not integrated with IP address, which management IPAM for address tracing or tracking and scope utilization or security forensic.